In this video, I will be looking at the 2016 AP Free Response question number 5. It is part of the non-calculator section, which becomes a little bit of an issue as you go through. There are going to be some trickier calculations we have to do by hand, but I'm going to try to go through this whole problem in under 15 minutes. No edits, we're just going to go right into the problem itself. So note this picture. We have a picture of a funnel with a height of 10 inches, and cross sections made of this funnel are all circles. And at any height h, the radius of the funnel is given by this function, r in terms of h. And our domain for h, 0 to 10, there's the 10 inches on the height. And units for everything in terms of lengths are all inches. So part A, first thing we're looking to do is find the average value of the radius of the funnel. And anytime you see those averages, we're thinking average value or average rate of change. This one specifically does say value, and it's finding a value for the function you're given. So we're going to be using our 1 over b minus a times the integral from a to b of our function. And I'll put this up in the upper left. So in this case, our 1 over b minus a, it does just say average value of the radius, so we're going to go for the entire domain, which was 10, from 0 to 10, times the integral from 0 to 10 of our r function, and we had r in terms of h. So that'd be the best way to write that notation. And then go ahead and just drop that function into our integral. And it does say find the average value, so we're going to have to calculate this one by hand, which means we'll need our antiderivative, use the fundamental theorem. One nice thing we can do is this constant 1 over 20. We can kick that to the outside, have it join with the 1 over 10, make this a 1 over 200, because now we'll just be doing the integral of some simple polynomial. And so the antiderivative here will be 3h plus 1/3 h cubed, evaluated from 0 to 10. The value on 0 is going to be 0, so I'm just going to focus on plugging in 10. Just make sure as you go through certain problems, especially if trig comes up, don't assume the second value is going to be 0 at 0. This one, hopefully we can see why. And you could leave that right there. It does say average value, so I would want to put inches on that, because the average value of r of h does return the same units as r of h. And being that I'm trying to show you can get this done in under 15 minutes, I'm not even going to worry about showing the final answer. You can find that on the scoring guide if you just look that up on the internet. Just Google 2016 AP Calculus Free Response. We're going to go ahead and move on to part B. And for part B, we're going to find the volume of the funnel. Now this one, the only things we've had with volume are talking about things like volumes of revolution, and this is going to be closely related to that, except this is actually going to be a volume by cross section. And the only thing we've seen with that before is building up 2D shapes from a surface. Well, here, a key phrase in the problem setup was circular cross sections. So in order to build the volume for this funnel, what I'm going to think of is, can I just define the area of one circle that I slice through? And integration will take care of adding up any circle anywhere along the funnel. So for part B, first thing, for one individual circle, its area would be pi r squared. Big thing is we're going to have to get that r in terms of h, because h was the only thing we were given a domain for. It's the only thing we have a start and end value for. And so our area in terms of h will be pi times that 1 over 20, 3 plus h squared. And we got to make sure we're squaring that whole thing. So our area actually becomes, putting a couple things together, the 1/20th squared would be a 1 over 400. Combined with that pi, we have an overall constant of pi over 400, and 3 plus h squared squared. And the expression that would give us our volume would be adding up all of those areas along the entire height from 0 to 10. And we'll turn all of these 2D areas into a 3D volume. But again, it does say find the volume, so we're going to have to do this one by hand. And we're going to do two things at once. First is, let's kick the constant out. That way it's just not distracting us. We just got to make sure to include it with our final answer. The other thing to note is that this 3 plus h squared all raised to the second power. Looks like it might be u substitution. We definitely have something inside this square. The problem is if you set up u substitution, just make a note to that, we can't u sub because we have no function outside this square. If we set u equal to 3 plus h squared, we'd expect to see a 2h somewhere. We don't see the derivative of the inside anywhere in this problem. So we can't u sub. Instead, that's just expanding a binomial to the second power, which would be the first term squared, plus 2 times the product, so plus 6h squared, plus the other term squared, h to the fourth. Or if you need to write it out the long way, realize that that came from doing 3 plus h squared times itself. Please don't just square both terms. Algebraically, we got to make sure to not make a mistake like that. And now we'll get our antiderivative. 9h plus, that should be 2h cubed, plus 1/5 h to the fifth, evaluated from 0 to 10. And just like the first one, as long as we can see why plugging in 0 will keep 0, all I really need to do is keep that pi over 400 and show that I'm evaluating this at 10. And again, don't waste time simplifying it. We're already close to 7 minutes in. We want to make sure we can get to this last part before our time would run out. Big thing on units. The volume, if everything was measured in inches, just remind yourself volume has to be those units cubed. Tack those on the end. And we are good to move on to part C. And we'll scroll down to use our space for part C. So for part C, the funnel contains liquid that is draining from the bottom. At the instant when the height of the liquid is 3 inches, the radius is decreasing at a rate of 1/5 of an inch per second. At that instant, what is the rate of change of the height with respect to time? So we have to realize the whole question is asking us to find, in a very specific notation, dh dt, our change in height with respect to time. We don't have anything to give us dh dt, but we do have an equation that would set up to give us radius in terms of height. And one thing I'm going to do to make this a little easier to work with, I'm going to go ahead and distribute right here. And you could have done that earlier in the problem as well. It's just I know what's coming up, so I'm going to go ahead and take care of this. And you should also know what's coming up. I'm not just trying to trick you on that. If I'm going to get dh dt, I'm going to have to differentiate this. And it's going to be a little bit easier for me to just visually look at the differentiation if I have this as just 2 terms, instead of possibly confusing myself with this constant times this little expression in parentheses. Because in order to get our dh dt into the problem, we have to differentiate this equation with respect to time. That'll give us dr dt. Again, r is not a t variable, so we have to denote that we are taking the derivative of this other variable. The derivative of 3 over 20 is 0, and the derivative of the 1/20th h squared should be 1/10 h, and again, variables don't match up, so we'll have a dh dt, which is great because dh dt is what we want. Problem is we need to make sure we find values for these two things, dr dt and the value for h at whatever time the problem is concerned with. And it does say at this instant, the one mentioned in the problem, the instant mentioned in the problem is when the height is 3 inches. And at that time, the radius is decreasing at a rate of 1/5 of an inch per second. Just realize the decrease means to put a negative, and our value is 1/5. And now we just got to plug the values into our rate function over here. Negative 1/5 equals 1/10, our height of 3 times dh dt. This one I will go ahead, just because of these being relatively simple fractions, go ahead and work this through all the way. All we need to do is get rid of the 3/10 off the side with the dh dt, and I can do that by just multiplying by the reciprocal. dH/dt will equal, and simplifying this down, should be a negative 2/3, and the units for height over units for time. I believe we had seconds. That's what it mentioned for the radius, so we'll keep going with that as well. And if you had just left the 10/3 times negative 1/5, that would be good to leave for an unsimplified answer. Negative 1/5 divided by 3/10 if you decide to divide both sides, that would also work out just fine. Either way, there's our final. And that came in at a little under 11 minutes. And that's with me saying everything all the way through. And if you're keeping that sort of internal dialogue as you go through a problem, hopefully you can hear some of the key things that I do to break these problems down and use that to help yourself when you're put on the spot and have to try to do this on your own. I'll be making a few more of these for some of the trickier problems that come up from 2013 to 2016. So please keep looking out for more videos on these select AP free response questions. Thank you for watching.